Hi, my name is Helen, and my presentation buddy is Loc. We had the same mentorship. Our mentor was Professor Jeff Price at Oklahoma City University, who teaches animation, graphic design, electronic media, etc. Today, we're going to be talking a little bit about the software we used during the semester. So I only just started my mentorship this semester, so I'm not going to have as much to say as Loc. I mainly just played around with this 3D modeling software called Maya. I have included a short 5-minute video from lynda.com, which is like the introductory video we all watched to learn Maya.
Let's start off by taking a quick tour of the Maya interface. Now, as you can see, there are a lot of buttons here, but if we break it down into its component parts, you'll find that it's actually fairly easy to navigate Maya. Now, like with any application, you do have a menu bar along the top. We have standard menus such as File, Edit. We also have Create, which allows you to create objects, Select, Modify, Display, which controls how you display objects, as well as Windows, which gives us access to a whole bunch of different types of editors and that sort of thing. And then once we get past Windows, we're going to have a bunch of different menus. In this case, I have Edit Mesh, and this means that I'm in the modeling menu set. Now, Maya has so much functionality that it can't fit everything into this one menu along the top. So we have our second interface item here, which is this pull-down menu, and I can go to any number of different menu sets. So in this case, I'm in modeling, but if I want to, I can go to rigging, and notice how all of these menus on the right side change. If I go into animation, I get all of my animation controls. If I go into rendering, I'll get rendering controls. Now, if we continue on this line here, you'll see we have a number of graphic icons that we can use, and these just mimic what we see in some of the menus here. So we have File Open, we have Save Scene, we have Undo and Redo. We also have some snapping options here that allow us to snap to grid and so on. We also have some rendering controls here. These allow us to render the scene. We have a window here which allows us to sign into Autodesk. And then along here we have some buttons that will change the right-hand menu. I'm currently have this button open, which is called the channel box. But if I want to, I can click any one of these and get a different set of menus. So we have the channel box here. We have some tool settings. Now this one actually comes up as a floating menu. So if I have different types of tools selected, then this menu will change. I also have what's called the attribute editor, which is very important, and this allows you to manipulate objects a little bit more deeply. For character animators, we have character controls, and we have a modeling toolkit for those who model. Now below this, we have what are called shells. Notice how we have this tabbed interface with a graphic representation of most of the major tools. So if you wanted to model curves or surfaces, you would select this tab. This tab allows you to model and manipulate polygons. We also have an animation tab and a rendering tab. And we can also create our own custom tabs if we want. Now along the left side, we have a number of standard tools here. We have a select tool. We also have a lasso select, which allows us to lasso something, and a paint select. So these allow us to select objects. And once objects are selected, we can move, rotate, and scale. And we'll get into these a little bit. Now we also have down here a number of preset layouts. Now right now I have one big viewport here, and this is what we would call a viewport. This is where we actually work. But as you can see, we have a number of different layouts. So if I wanted to, I could click on this button here, and this will give me a 4-panel layout. If I do this one here, it gives me 2 panels. This one gives me what's called the outliner along with some other panels. And if I want, I can go back to my standard panel. Now these panels can tear off, so I actually brought the outliner up, but I can left click on this and drag, and that will drag that off. And so if I wanted to, I could close it that way. Now along the bottom, we have a time slider for when you do animation, as well as a range slider. So we can actually zoom in on the time slider by left clicking and dragging this bar here, and then we can pan through that as well. Now along the right here on the bottom, we have some playback controls. We have playback speed controls here, which is really nice. And then we also have some additional tools here for looping and so on. Now along the bottom, we have a spot where we can actually type commands into Maya. We won't be getting into that. And then at the very bottom, we have a little helpline, and that will actually just tell us what various tools will do. So if we hover over a tool, notice how these change. So if you don't know what a tool is, just go ahead and keep this little tab open and you will get some hints. So as you can see, my interface looks complex, but if you break it down, it actually is pretty straightforward. And as we move forward, you'll start to learn how to use Maya, and it will become very natural to use.
Okay, sorry, that went on a little too long. So aside from watching the Linda videos, when I was just starting, I found it really helpful to look at step-by-step instructions like this one. I know in general that modeling faces is supposed to be really hard, but I found this tutorial in particular very helpful, just to get used to how to transform a simple polyhedron like a cube into something complex. You can see how they utilize different tools, etc. In Maya, you can also add colors and render things, but I did not do that because of time constraints. Okay, so these are my own projects. For the cat, I kind of got bored midway, so it ended up looking kind of like a block. For the sword, unfortunately, I am really bad at bookkeeping and I forgot to take pictures of my final work. So I only have these. You can kind of see the progression and how I did things. I first created a long rectangular block, and then tapered it at the edges and did the fancy hilt stuff. And then I mirrored it so that the sword is symmetrical. So the rocks, I think, look pretty good, but actually I just pushed and pulled the vertices until they looked right. Honestly, I think the tool that I used the most was the edge loop tool, which lets you insert an edge that follows the geometry of the object. It is very useful for creating more edges and vertices to work with. And also when you smooth your object, it makes it more defined. I also included the picture that I was working from. I think the end result was pretty much like that. So you can use your imagination. Sophie, who's not presenting today, was doing Unity. So I sent my final product to her and she was trying to animate it to make the sword come out of the stone. So pretty cool. So there was one day where everyone in the class went to the OCU mocap lab because they were just starting their motion graphic unit. And they were explaining how all the cameras worked and how the information got onto where it was recorded onto the screen. They had me and one other person put on the really tight black Velcro suits with all the stick-on balls and stuff that reflect on the cameras, and that's how they work. So unfortunately, we only had half an hour, so I pretty much just put it on and then took it off. It was still fun though. I wish I had gotten a picture, but I forgot. So you can just superimpose my face on that person.
Okay, now that Helen has talked about Maya and the mocap lab we did in one day, I'm going to be talking about Unity. So Unity is a cross-platform game engine developed by Unity Technologies back in 2005. Originally, it was only for OS Mac, like the Mac OS originally, but as of now, more than 25 operating systems are able to use Unity. And the engine can be used to create three-dimensional, two-dimensional, virtual reality, and augmented reality games, as well as simulations and other experiences. So if you see all those arcade machines with all these cool 3D looking models and all these augmented reality apps on your phone, they are most likely made by Unity. And this engine is also adopted by industries outside of video gaming, such as film, automotive, architecture, engineering, and construction. And I am more interested in the film and engineering aspect of Unity. So while I was in this mentorship, I was trying to learn C Sharp because at OSSM we learned Java, but we didn't learn C Sharp. So I had to pick up a new programming language. And I was about to make like scripts for my program in Unity, and I was about to like rework the Unity engine, but due to time constraints, we aren't able to do that. Um, Another important thing to point out about Unity is we can't really make like character models in Unity. We can only really make an artificial environment for our models and animate models to our liking. We could also add some effects to our landscape, but we can't really like actually like sculpt a model or like a building. So I'm going to be talking about my first model, which is this Pikachu right here. Of course, it doesn't really look like a Pikachu because I'm just starting to learn. But characters such as Pikachu are very difficult to model compared to if you were modeling a building or an object. Characters are difficult to model because you have to take into account of a head, body parts, and then you have to make sure like they're symmetrical so that you could use the model for animations in the future. So this Pikachu actually started off as a cube that eventually expanded itself. I use mostly to insert edge loop, and it's where, like Helen said, where we insert like edges onto a shape so that we turn one cube into two cubes stuck together because we have like this, we inserted an edge somewhere in between like a gap. And I also use an extrusion tool where I take a face, like you see these squares right here. So I took one of those and I extruded them so like I could expand like on the face and it like outwards. So I used that tool multiple times to create the arms and the tiny bitty fingers that are in or claws in the hand. And I used the mirror tool because I sort of cheated a little where I only like made half of the model and then I started using the mirror tool so I don't have to like do the exact same thing on the other side. And I also used the combine tool because even though this Pikachu started off as a cube, it the ears and the tail were not actually part of the cube. I had to make like I have to morph separate shapes and then attach it to the cube using the combine. tool. And because characters are difficult to model, this took around 60% of first semester to make, and it also reached out to second semester. And due to the unforeseen circumstances, I cannot texture this model, but I tried my best making the model, and it is complete, and I really do like the end product. So I also modeled the Dan Little Residence Hall. It's easier to model than most characters, well, probably all characters. But instead of like making this into like starting from one cube, I used a lot of geometric shapes to create this building. So like, for example, like one of the wings right here is one cube, but this base is like another cube. And I at first intended to like model this as like a Hollywood facade where you only see like the front, but you don't see the back. But I eventually changed my plan to that. And I also used the same tools as I did with my Pikachu, the insert edge loop, extrusion, mirror, and combine. And it only took 2 weeks to make this one compared to the Pikachu due to how simple it is comparatively. So Maya and Unity are different programs. I used Maya to model, but I used Unity as my main program second semester. And models, I have to export the model from Maya to Unity by changing the file type. A Maya file type is a .mb file, and I converted it to a .fbx file so that I could bring this model to Unity. And obviously, like compared to the shading right here, the shading in Unity is different because it takes into account light. And the controls between Maya and Unity are relatively the same. So I didn't have trouble like learning Unity because the controls are almost the same as Maya. And even though, as you can see here, all there is a sunset, and it's just a building in a checkerboarded landscape. I made a terrain in Unity rather than in Maya. I found it easier to make a terrain in Unity. So I did that. And so as you can see in the final product, there is like a grass here, and then there's a sky. And I used, I put some clouds in. I normally use textured images to help me build the terrain. So here's the quote unquote finished product. So I added windmills as a prop because it was my side project from a while back. So I included windmills as a prop before spring break, before like my last day of mentorship. So in my final product, I added gravity, wind velocity, etc. So like if I were to like activate the simulation, you would see like the windmills like spinning around because of the wind velocity. And unfortunately, due to unforeseen circumstances, I wasn't able to expand the residence hall to its full potential image. I was planning on like building the A wing and the B wing like right next to what I have so far. And that's pretty much how it ended. So I also attached a video of what Unity could do. Yes, it's an anime game that is on a mobile app, but it is used by Unity, and it uses its own like modified engine. So I'm gonna be only showing like a couple seconds of it before I end this presentation. So here you go. Okay, so me and Helen would like to thank the OSSM mentorship program, because without the mentorship program, we wouldn't have this unique opportunity to learn these programs. And I would like to thank Dr. Richards for helping us set up this mentorship program. And we would like to thank Professor Jeff Price for taking his time to teach us these programs, and OKCU for letting us use their computer labs. We actually were able to use like a very good desktop computer with 2 monitors, one where we could actually touch the screen. So it's pretty cool using that. And I would also like, I didn't put this on here, but we would like to thank Ms. Falaktu for for the assembly program. Without that, we wouldn't be able to be set up with this mentorship. So thank you for listening to our presentation. Are there any questions?
Good job, guys. I have a question. So you said that some of these software programs you can use for like engineering type of projects. Like how would you use this sort of thing in that context?
So I'm actually not too sure about how Unity could be used, but Maya models can be exported to AutoCAD because they are made by the same company, Autodesk, and it also has like simulations where it could test out some real what's the word for it?
Like, will it model the physics and like the stresses on materials and stuff like that?
Mm-hmm. It does model that. I know because through Maya and Unity, actually, I was able to like set up model gravity to negative 9.8, as we know, and I was also able to like add more factors into the program, such as wind velocity, and I could also incorporate some external like factors, such as I could possibly simulate an earthquake.
Cool. Let's see. Dr. Awad asks, is there any limitation in making a video like the one you showed versus an interactive game with players? Can you do that sort of thing in Unity, or is it just for modeling?
Unity, yes, it could definitely do something like that. And Maya also has the capability to do so. And there are external programs out there that has the capability to do so. I actually learned how to animate a long time ago, like using 3D models, using a program called Cinema 4D. But yeah.
Okay. Great.